Hi, my name is Rosemi Wang, and today I'm going to present my biodesign concept about problem facing on traditional leather market. From my perspective, all innovations are meaningless if we can't address the source of issue. So I want to build up a speculative system which can address the issue from many sides at the same time. This means I can invent a completely new industrial way to produce goods. During the last century, environmental concerns became more and more pressing. Beginning with water pollution in the 20th century, high labor costs in Europe leads to rapid business growth for leather production in developing countries. The issues are mainly from three fields: economic, environment, and ethics. Environmental issues contain water pollution, animal rights, and distinction of rare animals. It has been calculated that over 1.4 billion cattle have been bred for leather production. The scale of animal slaughter involved in the industry is unbelievably huge. This can all lead to environmental degradation such as deforestation and water pollution. So what is leather? It is one of the most important materials in the human earliest time, and is strong, flexible, and durable. Usually come from pigs, goats, and sheep. The manufacturing process contains three fundamental sub-processes and one additional sub-process called finishing. Coming back to the environmental issue, water pollutions are affecting agriculture and accessibility to the clean water. A high concentration of chromium is commonly used in tanning process. This not only causes more water pollution, but also allows dirty water to contaminate the soil, making it impossible for crops and vegetation to survive. As for ethical issues, workers are exposed to a wide variety of toxic and hazardous chemicals with heavy, largely, and unsafe machinery. This can result in injuries, asthma, internal and external infections, and subsequently death, cancer as well. A study published in 2021 found in Bangladesh, children are working at all processing stages of the leather supply chain. Researchers found that children as young as 8 years old were engaging in extremely hazardous work. So we need changes. Leather industry is facing new trends on production and consumption patterns due to society concern. People invented vegan leather. It is a material that emulates the look and feel of traditional animal-based leather, but is made from artificial or plant-based material. But this is not enough. The environmental impact of vegan leather production can be up to a third lower than that of real leather. It can still not fully biodegradable. So, how do we get the perfect vegan leather? I think Scooby can help. It is a completely new substance to the fashion industry. As a symbiotic fermentation starter, it has commonly used in the preparation of sour food. It is vegan, have low impact to the environment, low cost to company, biodegradable, and recycled and clean. The fiber of Scooby is 100% biodegradable. It can grow much more efficiently than leather and can be produced in any shape. Its production stage is completely eco-friendly. It doesn't rely on any animal products during the production. So this can address many issues which I have mentioned before. Despite the eco-friendly production and animal welfare, the cost of producing Scooby leather is also relatively low, only requiring freshly sweetened tea for the growth of the bacterial culture. Advantages of Scooby leathers are like extremely versatile, easy to clean, naturally antibacterial, and ideal for use in wet and humid environments. Various elements can affect the growth of Scooby, like variation in fermentation condition, type of tea leaves, and the growth tank parameter. So how should we set the fermentation conditions to make it maximize the growth rate of Scooby? First, we have to set the temperature between 20 and 30 degrees, then provide sufficient oxygen levels, high substrate concentration, and a pH value between 4 and 4.5. This is my statement of design. I want to create a facility which allows the workers to have clean and safe working conditions, as well as lowering the cost. All the materials I use are safe and 100% biodegradable. This can also increase the yield of producing. A simple machine needed, a container used for growing scoby, and a dryer for drying the foam. In order to be familiar with what actually affects scoby growth rate, and to improve my facility, I start to making receipt samples. This is my first outcome, which I have also mentioned in my first assignment. The sample is too fragile and too thin, so there must be something wrong with my recipe. I decided to do more tests and research about how to grow scoby. This experiment shows how I grow scoby in different tea. One is green tea and one is black tea. I also try to use natural dyes to see if there's any changes about the scoby growth rate. I use the coffee powder, and it's funny that the coffee powder will not kill the scoby but lower the scoby growth rate. And I also replaced the apple acid vinegar to the rice vinegar to see the growth rates change. The result of rice vinegar causing the scoby is too thin and too fragile. It's just like paper. Then I decide to find out how different types of sugar will affect the growth rate. There's actually huge differences between these three types of sugar. Glucose is a monosaccharide, mainly made from plants by photosynthesis from water and carbon dioxide. Honey is a sweet from bees, and sugar is made from the concentrated sucrose, which can usually found in the tissues of most plants. And here are some of my outcomes. After 3 weeks, the scoby fed with honey and glucose in green tea is much more thicker than the one grows in black tea. Here's my sample with honey and glucose fed, which is the thickest sample that I have ever had. The photos on the right side clearly shows how different types of sweet affect the growth rate of scoby. While I was testing if scoby can live inside the floral tea, I got an interesting result. My scoby seems to get moldy after 2 weeks. After my further experiment, I found that it is not mold, but brown fluorescent impurities. After washing and cleaning, my scoby continues growth and grows healthy. I made a conclusion about how different factors affect the growth rate of scoby and have numbers inside the chart. I found those key images to show what my apparatus looks like and how does it actually works. The whole production process will be simple, safe, clean, and have low cost. My final outcome will be 100% biodegradable, and this means it has no impact to the environment. I really hope that one day my facilities can be used in fashion industry to create more scoby leathers to the market. Finally, here's on my reference list. Thank you so much for listening.